In this section, you can actually see the science that our claims have been based on. And again, this is very technical, so do skip over it in case you're not interested in the science and only in what it actually means for you. But in case you are interested, or in case somebody who knows something about genetics is interested in what kind of genes are being tested and how come we believe that these genetic variations cause the things that we say they do, you can go to this section and review the science of every single genetic variation. So it looks something like this. So for every gene, this for example is the HHEX gene, you see the name of the gene as well as the RS number. As I've explained it before, this is the catalog number of the genetic variation that we're interested in. Now you find a very short explanation of what this gene does. This, in this example, is a diabetes gene, and you can see that there are three possible outcomes for this gene. So this genetic variation might have an A on both positions, so both copies of this HHEX gene might have an A at a certain position. This is what A/A means. Or one of them might have a G, the other one has an A, or both, like in this example, both have a G. And in this case, A means that the gene works normally, so this person has two copies of a functional gene, usually not an increased risk of disease. The G means this gene does not work normally, so this person has one, you could say, broken gene and one functional gene, or you could have two copies of the broken gene. And here the POP column will explain to you how common this genetic type is. So 17% of the general population have the genotype AA. So 70% of people around you will have AA, so two functioning genes. Around 50%, so it's quite common, have one defective gene, one broken gene, and one normal gene. And 33% have two defective genes, two broken genes. So here you can see how common it is, and this arrow here will tell you what your result is. So in this example, this person has AA, the same as 17% of the general population, and this then explains what it means to you. So this means that there's no increased risk of diabetes type 2. If the person had the X here, it would mean one broken and one functional gene, like 50% of the general population, and it would increase the risk of type 2 diabetes by an odds ratio of 1.21. This means the risk of the disease is increased 1.21 fold. So there's a 1.21 fold higher risk of developing diabetes due to this genetic profile. You could also explain it as there's a 21% higher risk of developing the disease compared to people with the optimal genetic type, which is AA in this case. And if you have two broken copies, as you would expect, the risk of developing diabetes is higher, so there's a 1.44 fold risk, or a 44% higher risk of developing the disease. Now, again, this is just one part of the whole story of diabetes, so you have to look at all of the genes together to understand what the total risk means, but certain genes can increase your risk, others can protect you from it, and if you then look at the whole picture, you find out what the final risk is for you to develop the disease. And down here you find the references, the scientific studies that have found these kind of things. Now, these are usually only the best studies. There are plenty more studies. In many cases, there are several thousand studies per gene. So a lot of these things, a lot of these genes have already been evaluated by many scientific groups, and they've all found the same things. And in case you might know someone who wants to review the science to see how we came to the conclusion that this is indeed an increased risk, they can look up these these papers, and they can download it on the internet, and they can read it and find out how scientists have found out that a certain genetic combination increases the risk of developing a disease.